Now, let's talk about the fuel pressure regulator. The job of the fuel pressure regulator is to maintain a constant fuel flow across the injectors under all operating conditions. To do this, the fuel pressure regulator is typically referenced to the manifold pressure. This is the vacuum hose that you'd find on the top of the regulator going back to the inlet manifold. Using this manifold pressure signal, the fuel pressure regulator is able to increase the fuel pressure as the manifold pressure goes up and decrease the fuel pressure as the manifold pressure goes down. Doing this results in a constant flow. For example, if we have 45 pounds of fuel pressure supplied to the top of our fuel injector and we open the injector for a specific amount of time, we can determine how much fuel passes through the injector. The problem occurs when we change the pressure at the bottom or the discharge side of the fuel injector. If I had 45 pounds on the top of the injector and then I put a vacuum cleaner on the bottom, that would allow more fuel to pass through the injector. Conversely, if I have 45 pounds of fuel pressure on the top of the injector and I had 45 pounds of fuel pressure on the bottom of the injector, when I open it, no fuel's going to flow. No fuel flows because there's no difference in pressure, so there's no motivation for the fuel to move. If the fuel pressure regulator is not referenced to manifold pressure, which can be found in many late model applications, the fuel injector flow rate actually changes with manifold pressure. If the manifold pressure increases, the injector flow rate decreases. Likewise, if the manifold pressure decreases, the injector flow rate goes up. Because of this change in pressure, we need a calibration table to determine the injector flow rate versus the intake manifold pressure. If we don't, the numbers in our volumetric efficiency or base fuel table will become skewed. As the fuel injector flow rate gets smaller and smaller, we'll have to use a larger and larger number in the base fuel table in order to achieve the correct amount of fuel flow. The opposite happens when the fuel injector flow rate goes up. That means that we'll be supplying more fuel than we require, so the numbers in our table will have to get correspondingly smaller. In this way, the volumetric efficiency table becomes skewed and no longer represents just the airflow of the engine. It would be representing the engine airflow and the change in injector flow rate. Referencing our fuel pressure regulator to the manifold pressure eliminates this problem and makes tuning the engine so much easier.